Hello, today you're watching this video to hopefully move up a level on your 3.4 standard. I can graph systems of linear inequalities. I want to start really quickly about reviewing a few important things that you have to remember when you are graphing linear inequalities that we talked about, um, not even when they are systems, but just when we're graphing inequalities. First thing that you have to remember is paying attention to whether you are going to be drawing a solid or a dotted line. Remember, a solid line is going to be less than or equal to or greater than or equal to, and a dotted line is just that less than or greater than sign, meaning that that line that you draw does not include the values that are on that line. The second important thing is to make sure that when you are solving your inequality or putting it in slope intercept form, which is what I assume most of you will do, don't forget to flip your inequality sign when you multiply or divide by a negative. So if you are rewriting your inequality so that it's in slope intercept form, make sure that you're remembering to flip. Otherwise, your shading for your inequality will be incorrect. So let's look at an example if we're talking about systems of linear inequalities. Example 1 here, I have y is less than or equal to, sorry about that less than or equal to, that should be this sign right here. I just can't do it on my little screen. Negative 2x minus 1. So first thing I'm going to do is graph that. It's already in slope intercept form. Go down to negative 1, and I'm going to go up 2 over 1 in a negative direction, or I can go down 2 over 1 either way. And then when I draw my line, I'm going to make sure that I pay attention. It has a less than or equal to sign, so this is going to be a solid line that I draw through those values. And then the next thing that I want to do is figure out which side of my line I'm going to shade that is a solution to this. So the most common way is to plug a 0 in for x and a 0 in for y. So I would have 0 is less than or equal to negative 2 times 0 minus 1. So that's saying that 0 is less than or equal to negative 1, which we know is not true because negative 1 is smaller than 0. So this is not true. So this coordinate right here, 0, 0, the one that I tested, is not a solution. So that's indicating that everything to the left of the line is going to be a solution to my inequality. And if you wanted to make sure, you could always test a solution as well as a non-solution. So if I checked negative 2, 0, and I put a negative 2 in for x, and I put a 0 in for y, and checked that one, 0 less than or equal to, this is a positive 4 minus 1 is 3. Now this is a true statement, so it is verifying that we do have a solution. My second line or inequality, that I'm going to draw is 3x minus 4y is a less than negative 12. So since this is in standard form, I can have a couple of choices. I could rewrite this in slope-intercept form, or I could do my intercepts. So I'm just going to, since we did one in slope-intercept form, I'm going to do this one in using my intercepts that we learned earlier this year. So if x is 0, I have negative 4, y is less than negative 12, so I divide by negative 4. So then I would get y is greater than 3. I have a 3 here. And if I went through and put a 0 in for y, and then I divide by 3, I get a negative 4. So my 2 points that I'm going to graph on my y-intercept, I'm going to go up to 3. On my x-intercept, I'm going to go over 1, 2, 3, 4. And this time, get rid of my scribbles here, I'm going to have a less than sign. So when I draw my line, I have to remember to make sure that it is a dotted line that I'm going to draw. And then I'm again going to check a solution. So if I wanted to check this 0, 0 again to decide if I want that upper portion or the lower portion, I would say, well, if I put a 0 in for this and a 0 in for this, is 0 is less than negative 12? No, that's not true. So this time I'm going to be shading this portion right here. This section of your graph, I'm just going to highlight really quickly. This section of your graph is the section that should be solutions to your system of inequalities. So I could check both of those by plugging in a point. So let's pick 1, 2, 3, 1, 2, 3. Let's pick this point right here, negative 3, 3. So if I put negative 3 in, negative 3, 3 in, I have 3 is less than or equal to negative 2 times negative 3 minus 1. I have 3 is less than or equal to 6 minus 1 is 5. Yep, that checks out. The second one, if I put 3 times negative 3 minus 4 times 3 in there, is less than negative 12. So I have negative 9 minus 12. So I have negative 21 is less than negative 12. Yep, that one checks out too. So I know that I have my system shaded correctly. So again, really quickly, make sure that you're paying attention to solid and dotted lines, and then make sure that you're checking a solution or a non-solution for each of the lines that you draw to determine whether you are going to shade them or not. And then the parts of the graph that are shaded, double shaded, are going to be the solution set for that system of linear inequalities. The second example that we're going to do is if we kind of work backwards. So this time we have a graph and it already has pieces that are shaded, and you can see this little triangle right here is, oh, it drew a triangle. That little triangle right there has both the red, the green, and that purple color all shaded in that triangle region. So any values that I would put into any of those would be that solution set. So I'm going to start by writing, and of course I'm going to probably, what 99% of you are going to do is write these in slope-intercept form. So I'm going to start with that red dotted line. So I'm going to write plus 2. That's where it hits the y-intercept. And I can see it's going down 1 over 1. So it's a negative 1x. And then I'm going to check this solution right here. And I can see that it's shaded red on the bottom half. So this should be a solution. So if I put a 0 in for y and a 0 in for x, 0 is less than 2. So I know I'm going to do a less than sign because that's a true statement. If I move over to the green line, I'm going to write y, and here it hits at negative 2, and it goes up 1, 2 over 1, so 2x minus 2. And again, this should not be a solution this time because it's the right side of that line that is shaded. So if I put a 0 in for y and a 0 in for x, 0, and I have a negative 2. Well, if we want it to be true, it would be eating the 0, but we want it to be false. So 0 is not less than negative 2. And of course, it has a line underneath because that's a solid line. And then that third purple line happens to be not an X, a Y, a horizontal line at -2. And we want this 0, 0 to be a solution. So we want, if we put a 0 in here, we want it to be true. So 0 is greater than -2. And we add that line underneath to indicate that it's greater than or equal to. Okay, there's a couple steps that you have to worry about. One, paying attention to your inequality sign. And you can decide your inequality sign based on putting a solution or a non-solution in. It doesn't always have to be 0, 0. I just like to work with zeros because they're easy to multiply, add, and subtract by. And then you just go line by line and determine. If I were to then check a solution or a non-solution of this, so if I chose 2, -2, that should be a solution to all of these. So if I put in a -2 is less than -2 plus 2. Well, yep, -2 is less than 0. I put a -2 less than or equal to 2 times 2 minus 2. Well, 4 minus 2 is 2. -2 is still less than -2 or to 2. And here, if I put a -2 in, less than or equal to -2. Oh, it's equal to. So that is a solution. So that proves that that triangle area is the solution to all three inequalities. All right, it is now your turn. So you have 6 problems that you're going to do for me. The first 3 problems, get them small enough so that you can see. For the first 3, you are going to graph those systems. So the first 2 have 2 inequalities. The third one has 3 inequalities, so it's going to be similar to the example that you did here. And then in 4 through 6, we're going the opposite way where the graphs are provided for you, and you have to write the inequalities that make up that system. So go ahead and write these down. I will make this a little bit larger, so pause if you need to. And then I can make the graphs larger for when you're ready for that part as well. When you are done with these 6 problems, you are going to make an appointment to have an interview with your teacher. Don't forget to bring these 6 problems with you. And hopefully you have proven that you can move up a level on your 3.4 standards-based grade. Good luck.